summarise. Okay. There's a couple more things we can go to from here. If there are two real roots, what else can we know about those real roots? What else can we know about those real roots? And so, we can also ask the question, is the discriminant, does the discriminant consist of perfect squares? If yes, then our roots are going to be rational numbers. What do I mean by that? So remembering where we get the discriminant from, it's inside the square root sign, inside that quadratic formula. And so, if we have inside the square root sign perfect squares, for example, if we discover that our discriminant equals 9, when I take a square root of 9, the answer is 3. That's still a rational number. And so I'm going to find that my roots are rational numbers. But if I found that my discriminant equals 8, when I take a square root of 8, the answer is 2 root 2. They're not going to give me rational answers, they're going to be irrational roots. Okay, so if we know that what's inside that square root is a perfect square, then we can say something more about the roots, that they are rational. Or they consist of perfect squares. You may have one, the discriminant equals 9 over 16, but they are made up of perfect squares. So when I take a square root of 9 over 16, it'll be 3 over 4. Okay, and so if we've got perfect squares, we're going to have rational roots. The other thing we can say from our discriminant is in this case here where the discriminant is less than 0. If A is greater than 0, so if the x squared coefficient is positive, then it's going to be like that green one up there. It's going to sit all above the x-axis. The function itself is always going to be greater than 0. And if A is less than 0, the function itself is going to be less than 0 as well. To give an example of that, the one that we did just before, the example, which was x squared minus 2x plus 4, that's the function of x. We found that that discriminant there was less than 0, so it had no real roots. But the x squared term itself, the leading term, is positive. The coefficient is greater than 0. And so it's going to be exactly like this one here, where it's going to be all above the x-axis. Okay, and so that's just, I guess, another kind of way of differentiating between different quadratics. If in this case here, where there's no real roots, if A is greater than 0, the function itself will always be up above the x-axis. If A is less than 0, the function will always be down here below the x-axis. The function itself will always be less than 0. At no place can that function be positive.